Sewage is the most general term used to define all kinds of liquid waste resulting from a community. From the public health point of view, it is important that all kinds of liquid waste resulting from a community, as and when collected, should be promptly disposed of after treatment. Sewage can be disposed of either on land or in a large water body. One of the practices commonly adopted is that the sewage is discharged on an open land or in a pond nearby. This way of sewage disposal will create unhygienic and insanitary conditions for the community. This will result in breeding of mosquitoes, flies, and all kinds of bacteria that may cause outbreak of diseases. It will not only spoil the aesthetic appearance of the city, but also pollute the nearby water table, and thus can lead to spread of epidemics. In general, it can be said that sewage disposal in this way is a threat to public health and especially to the people living nearby. But if sewage is discharged directly into the river without treatment, it will pollute the water and endanger aquatic life. This water as such would be unsuitable for human consumption. These considerations point the way to the systematic collection through underground system of drainage and its treatment before disposal. Sewage treatment means the process to which sewage is subjected to remove its objectionable constituents. Take a look at a sewage treatment plant where domestic sewage is being treated. Let us understand the layout of a sewage treatment plant through a line diagram. First of all, raw sewage passes through the bar screens. Thereafter, it enters the grit chamber where inorganic matter is removed. After this, sewage enters the primary settling tank, where heavier suspended organic matter settles down. The settled material, which is known as sludge, goes to sludge digestion tank. The effluent from primary settling tank enters the aeration tank for secondary treatment. After aeration, sewage enters the secondary settling tank for final sedimentation. A part of settled sludge goes to aeration tank. The remaining extra sludge goes to the sludge digestion tank. Finally, the effluent is disposed of or used suitably. On the other hand, sludge which has gone to the sludge digestion tank undergoes digestion, and digested sludge is sent to sludge drying beds, which is finally used as a manure. Sewage treatment is carried out in two stages: primary treatment, secondary treatment. In primary treatment, sewage passes through bar screens, grit chamber, and primary settling tank. Sewage first passes through the bar screens where floating and suspended matter such as wood, paper, rags, etc. are removed. The waste material which is retained on bar screens may be lifted and removed mechanically with the help of conveyor belt arrangement. After this, sewage enters into the grit chamber. It is an enlarged channel in which cross-section is increased to reduce the velocity of flow. This causes settlement of heavier particles while the lighter ones remaining in suspension. These bars are provided near the inlet to the grit chamber to keep the velocity approximately constant. The central drive unit operates the scraping arms, causing the settling material to get deposited towards the sump. A mechanical arrangement is commonly adopted for the removal of settled material from the grit chamber, which is finally disposed of by transportation. Suspended solids, which are too fine to be removed by screens and too heavy to be removed by flotation, are taken out of sewage by allowing it to quiescent through sedimentation in the primary settling tank. Screen sewage is fed from the bottom of these tanks by means of inlet pipe and is guided by circular baffles near the center. A detention period of 1.5 to 2 hours is allowed at this stage. It then flows over the peripheral weir and enters the effluent channel. Scum is removed by means of a scum remover, which moves over the liquid surface and drops the scum into a sump. This scum then enters a scum collection tank from where it is finally disposed of. The raking arms operated by the drive unit gently agitate the sediments with the flocks to form sludge. This is then removed through the sump and discharged into sludge collection tank. Sewage treatment at the primary stage must ensure removal of 60% suspended solids and 30 to 35% BOD. The clarified sewage, carrying mostly colloidal and dissolved solids, passes out as effluent for secondary treatment if necessary. The treatment of sewage with bacteria is known as secondary treatment. It is carried out to remove the non-settleable organic matter which is present in the primary effluent. The various methods of secondary treatment are intermittent sand filters, contact beds, low rate and high rate trickling filters, and activated sludge treatment process, which is explained here in detail. During the activated sludge treatment process, the effluent from primary settling tank is passed through aeration tank for further treatment and to prevent septic conditions. This aerated sewage is passed into secondary settling tank for removal of activated sludge. Part of this sludge is recycled into the aeration tank. Whereas the remaining sludge goes to the sludge digestion tank. Finally, the effluent is disposed of or used suitably. Now, a closer look at the aeration tank. In here, mixture of effluent from primary settling tank which contains non-settleable organic matter and activated sludge recycled from secondary settling tank is passed on into the aeration tank. Here, these are subjected to aeration and agitation by high-speed impeller action for about 6 to 8 hours. The primary purpose of aeration is to supply oxygen to sewage for maintaining aerobic conditions. Some of the main internal features of the aeration tank that can be seen here are baffle wall, central uptake cone, and impeller blades. Baffle wall increases the path of sewage flow. The blades of two adjacent tanks rotate in opposite directions. This ensures more effective aeration and agitation. Aerated sewage goes on to a secondary settling tank for final settlement of secondary sludge. The secondary settling tanks are similar to primary settling tanks but have a detention period of 2.5 to 4 hours. Part of settled sludge goes to the sludge collection tank, which also collects the sludge from primary settling tank. Sludge is passed on to the sludge digestion tank for anaerobic decomposition of organic matter. This process is known as sludge digestion. Raw sludge is pumped into the center of tank for a detention period of about 4 weeks. Gases are released through a dome at the top. At the same time, supernatant liquor and scum are removed from the sludge digestion tank. Digested sludge settles down and passes on to sludge drying beds. Dried sludge, which is rich in nitrogen, is used as a manure. Resultant effluent from secondary settling tank is free from suspended solids and BOD to the order of 90 to 95%. Finally, this relatively harmless wastewater can now be used for irrigation and other purposes.